Good morning. Am I audible? Okay. Good morning, Priyank, Abhi, Keval. So I think now it's a while we had last lecture. I was on leave. Fine. We'll continue from that point. In the previous lecture, we had discussed constructing a Turing machine for accepting the language of palindrome. The next example is for accepting the language SS. L equal to SS, where S belongs to AB star. The assumption sigma is A comma B. So our strings are comprised of A's and B's. And meaning of SS is my first part symbols same as the second part symbols. For example, A double B, A double B. So first part is A B B, second part is A B B. So all such strings belong to the language. I think we started this topic L2. L1 and L2 are the languages which cannot be accepted by other models of computation like PDA or finite automata. So that L2, it is SS where S belongs to AB star. Now we'll construct a TM that would accept the language L2. Was our previous example, the last example of the previous lecture, accepting the language of palindrome. Then we also perform the execution trace for a string that is not a palindrome, a string that is a palindrome. The second execution trace. Prior to that, if you recollect, then we constructed a TM for A plus B star ABA, A plus B star ABA, A plus B star. This is A plus B star ABA. This is A plus B star ABA, A plus B star. That was first example. This is A plus AB, A plus B star ABA. The second example, strings ending with ABA. We constructed a TM, and then the TM for accepting the language of palindrome, both odd length palindrome as well as even length palindrome. So those were three examples. Fourth example is constructing a TM for accepting the language of SS. Now, here, the main challenge would be what is the main difficulty in accepting the language SS? Any idea? What is the main difficulty? Try to think on that. Maybe Keval? Main difficulty in accepting the language SS. We don't know where the second, Priyank, correct, but we don't know where the second half begins. We don't, size of the input can be anything. Yeah. Where is the middle character? Where is the second half begins? We have to process any length string. There's no constraint on the length of the string. Yes, Priyank. So we have to find out where the second half begins. Once we identify that, then we can match. Suppose my input is A double B, and if somehow we can find out that from the fourth character from the left, my second half begins, then I can match the first A with the fourth A, the second B with the fifth character, that is B, the third B with the last character, that is B. So exactly we have to identify where the second half begins. And to be of the form SS, the string has to be even in length. If it is odd, it can't be of the form SS. So we have to first verify that the string is even in length, number one. And in case it is, we need to find out where the second half begins. So these are important tasks that are to be performed. So that is, we are dividing these tasks into two parts. Part 1, in constructing the TM, part 1 would take care of ensuring that the string is of even in length, the string is even in length, and in case it is even, we'll place the head accordingly, either to the last character on the first half or at the first character of the second half, so that we can perform matching. So that is phase 1, and then in phase 2 we will perform matching, that is Q1 to Q4. That is for identifying whether the string is even in length, and then positioning head appropriately, Q1 to Q4, and Q1 to this Q9 or up to HA will perform the matching. The bottom part, Q1, Q5, Q6, Q7, Q8, Q9, HA, that is for performing matching. So let's go to the first part, first piece. Repeat steps 1 to 3 till no lowercase letter is left. Here's our procedure. For part 1, identifying whether the string is even in length, and then appropriately positioning the read head. Here is the procedure. Repeat steps 1 to 3 till no lowercase letter is left. Convert first symbol to caps and move right. Move to the rightmost lowercase letter and convert it to uppercase. So here we are taking the palindrome approach. To recollect, in the case of palindrome, what we did, we took the leftmost symbol, this part, we took the leftmost symbol from Q1 to Q2, Q3, Q4, that is Q1 to Q2, and then Q3 to Q4, we were matching from the extremes and converting matched symbols into the blanks. You look at Q1 to Q2, A blank R, and see Q3 to Q4. So we have found out for the leftmost A, the corresponding character in the right, if they are matching, make them blank. So from those extremes, we are moving to the center. Same approach we will take here. We'll convert first symbol to the caps and move to the right. So that is our marker. We'll read a symbol and convert into the uppercase letter, and then move to the rightmost lowercase letter and convert it to the uppercase letter. So per iteration, we are converting two lowercase letters into equivalent uppercase letters without matching. We don't care about matching right now. We want to find out that the string is even in length. So per iteration, we'll convert two lowercase letters into the uppercase letters. So this will follow steps 1, 2, 3, move left till uppercase letter is found, because from the extreme we are moving to the centers. Leftmost lowercase letter, convert into the uppercase letter, rightmost lowercase letter, convert into the uppercase letters. Only in between we have lowercase letters. So we'll go to the leftmost uppercase letter to prepare for the next iteration and then move towards right. So here are our moves actually. Q0 to Q1, our typical move, first move, blank blank R. Our input format is blank X. Content of cell number 0 is blank. The input that is to be decided whether it is of the form SS, that begins from cell number 1. The tape is divided into cells. The leftmost cell is having number 0, which is for our reference. Otherwise, a TM does not recognize these tape by these cells by numbers. As per our reference, leftmost cell is given number 0. My input begins from cell number 1, and after the input is over, we have infinite number of blanks. So blank X is our typical input format. I don't know if I've written that. Let just once again I will show that. Okay, later on I think we'll see that later on. Fine. So that is my input, and my first move is blank blank R. That is almost always the typical move. Blank blank X, blank blank R. Q0 to Q1, blank blank R. So we are going to the first symbol in the input. Input begins from cell number 1. initial position of the red, that is our cell number 0. Because of the displacement R, we are going to cell number 1. Current state is Q1. Now our those steps 1, 2, 3 will come into the picture from Q1 to Q4. So Q1 to Q2, the assumption is sigma contains two symbols A, comma B. So either my first symbol is A or B, and transition is between Q1 to Q2. So whether it is A or B, we convert that into equivalent uppercase version. So as soon as we process a symbol, we convert that into the uppercase version. That is our marker. Whatever is in uppercase version, that has those symbols have already been considered. The symbols that are in lowercase version, they are yet to be considered. That's our strategy. So Q1 to Q2, my first symbol, the leftmost symbol is either small a or small b. We convert that into capital A, capital B, and the displacement is R because we are going to the rightmost symbol, which is in lowercase letter, and we'll convert that into the uppercase version. So per iteration, we'll convert two small case letters into uppercase version. Ultimately, we have to ensure that the string is even in length. So that is Q1 to Q2, small a, capital A R, small b, capital B R, and then in Q2, while moving towards the right, we are skipping all lowercase letters because we'll process them later. And as soon as we get in the first iteration, we'll find a blank. Suppose my input is A double B, A double B. So leftmost A, I have converted into capital A. And then remaining small a's and b's, we have skipped because of the moves small a r, small b r in the state Q2. Leftmost small a, we have converted into capital A. Then skipped all small case letters. Eventually, because of the displacement R, we'll get a blank. A double B, A double B. After that, we have all blanks. So after last B, I perform small b r. That is for the last B in the input. My head will be positioned over the first blank after my input. So in the first iteration, I'll get a blank. So I say blank blank L. I go to the last non-blank character. Blank blank L. And second iteration, we'll see that. Okay, first iteration, I'll get a blank. So we do blank blank L. We go to state Q3. In the leftmost symbol, whether it is A or B, we don't worry. We are not matching. In the first phase, we are not matching. Just we are converting two small case letters into uppercase letters. So it's -2. Every iteration we are performing, we are ignoring, we are matching to, and it is -2. So in the state Q3, we'll find the rightmost small a or small b will convert into capital A and capital B respectively. We are not changing the we are not changing the content except the uppercase version, because later on we have to perform the matching. So for small a, we cannot do capital B, or for small b, we don't do capital A. We preserve the character only in the uppercase version. Only difference is we are preserving that in the uppercase letter, because ultimately we have to do matching. First half same as the second half. So later on we have to do matching. So in the state Q3, we'll find the rightmost small a or small b. We convert that into respectively capital A, capital B, and then we move towards left because we have to prepare for the next iteration. Currently we're in the state Q4. We started moving towards left. We started returning. We continue returning. So in the state Q4, we find small a L, small b L, and ultimately we'll get a capital A or capital B, because we started in the state Q1 by converting small a b into equivalent capital A, capital B. So eventually in the state Q4, we'll find capital A or capital B. We know that a character to its right, that will be my first character of the new pair that I will consider in the new iteration. So when we find capital A or capital B, we again position head to the right so that we can start the next iteration. So in the state Q4, the other moves are capital A R. That is the third move. The fourth move is capital B R. We position head to the first character of the new pair. When we go to the state Q1, we go to the state Q1 and position head over the first character, which is in the lowercase in the new pair. So that is what we repeat. Now again we continue with this A example. What we have done, leftmost small a converted into capital A, the rightmost small b converted into capital B, and again we have written, and my head is positioned over the first B, ABB. Now the leftmost A is capital A, then we have small bb, then AB, which is small, and that last B is now in the capital. State is Q1. So again we'll find B. We repeat the process, convert this B into capital B, skip all small case letters in the state Q2, and now we'll find capital B. For the first time we'll find blank. Now we have already converted in the extremes, leftmost side and rightmost side, we have capital letters. So instead of finding blank from second iteration onward, we'll find either capital A or capital B. In our example, that was ABB, we'll find capital B. Rightmost character, that is capital B. So that capital B, once we get capital B, we know a character to its left, that's the second character of the current pair. So we perform BBL, and now the second character from right will be either small a or small b. We convert that into capital A, capital B, and again repeat the process. Continue moving towards left, positioning head or the first character in the new pair, returning to the state Q1. So from the extremes, every per iteration will convert two small case letters into the capital letters. Eventually will reach the middle center, assuming that the string is even in length, will return. So in the state Q1, when we get a capital letter, we know that my matching is over. My string is even in length, and my string, the verification whether the string is even in length, that is over. Finally, we'll, in the state Q1, we'll get a capital letter. And because of this R displacement, returning from Q4 to Q1, because of the displacement R, the head is positioned. The head will be positioned over the first character in the second half. When we return from Q4 to Q1, because of the displacement R, the head is positioned over the first character in the second half. Now, by this, AL, BBL, if the string is odd in length, will be struck up in the state Q2. Will be struck up in the state Q2, we won't have any move. So the crash will happen, string cannot be of the form SS. Otherwise, finally, we won't get in the state Q1 either small a or small b, we won't get that. If the string is even in length, finally, from the extreme we are moving this towards the center. Ultimately, we will not find small a or small b, but we'll find capital A or capital B. And in that case, we are positioning head to the last character in the first half by this AL, BBL. We are moving to the last character of the first half because of the moves AL, BBL. Because of this AR, BBR, transition from Q4 to Q1, because of AR and BBR, the head was positioned over the first character in the second half, and everything is in the uppercase version. What are we doing? Now we know that the string is even in length. So from the state Q1, we are moving to the state Q5 and going to the last character of the first half. And the reason is, now I have to identify all the characters of the first half. I have to segregate the characters of the first half and the characters of the second half, so that I can perform matching. Again, continuing with our example, ABB. As of now, everything is in capital letter. ABB, everything is in the capital letter. Head was over the first character in the second half, and because of this AL, BBL, because of AL, my first three characters are capital A, capital B. Next three characters are capital A, capital B, capital B. So because of this AL, from Q1 to Q5, my head is positioned over from left the third character, which is B, A, B, B. So what are we doing now? We will convert this first half once again into the lowercase letter. The reason is to separate out the first half and the second half, because we have to perform matching. I have to match the first character of the first half with the first character of the second half. So what we do in the state Q5, AAL and BBL, capital A, small a, L, capital B, small b, L. While moving towards left, we convert all the capital letters into the small case letters, so that now we have complete idea of what is my first half and what is my second half. So in state Q5, the moves are capital A, small a, L, capital B, small b, L. Because we are moving towards left, ultimately, as there is a fixed left hand in the tape, so we'll reach cell number 0. And in cell number 0, we know it is blank. My input begins from cell number 1. So as we were moving towards left continuously and converting capital letters into the small case letters, these are all characters of the first half. We will reach cell number 0, where we will find blank, and finding blank, we'll go to cell number 1, so that we can start matching the first character of the first half with the first character of the second half. My first half, now it is in the lowercase letters, the second half, that is in the uppercase letter. So state Q5, one more move is blank blank R. We have reached cell number 0, we are going to cell number 1, and here from state number Q6 will perform matching. So we have identified that my string is even in length. I have converted my first half into the small case letters. My second half is currently in the uppercase letter. Position of the head, that is over cell number 1, that is the first character of the first half, which is in lowercase. I'll match this with the first character of the second half for the string to be of the form SS. Up till this point, is this clear? Up till this point, is this clear? Priyank, fine. Keval, fine. Love, Dev, Jainil, Abhi, Munaf, okay. Devansh, fine. So right now we are in the state Q6. My first phase is over. Now we are going to phase number 2, where we perform matching. So in the state Q6, from the state Q6, again, we'll read A over B. My first half, it is in lowercase. So the first character of the first half would be either small a or small b. So those are two different possibilities, two paths from Q6, either to Q7 or to Q8. If my first character in the first half is small b, I go from Q6 to Q7, and if that is A, I move to Q8. That is Q6 to Q8. Once again, as a marker, whichever character I read in the first half, currently everything is in the small case letter, I convert the character into the equivalent uppercase version. Again, that is a marker. So in the first half, whatever is in capital letter, at any point of time, it means they have been matched. Whatever is in the small case letter, that is yet to be matched. So that is my, once again, the strategy. State is Q6. My leftmost first half character could be either small b or small a. I convert that into capital B or capital A, and move towards right. Right, because my second half, that is towards right. In between, I have remaining unmatched character of the first half, which are all in small case letters. So in the Q7 and Q8, you'll find the moves are AAR, BBR, AAR, BBR. I have started moving towards right, which means I have started moving towards the second half character, which I have to match. So as a marker, small b or small a, I have converted into capital B and capital A. In the first half, reach either Q7 state or Q8 state. And once I reach there, let us take the example of Q8 state. My input is A double B, which is in small letters. After that, I have capital A, capital B, capital B. So Leftmost character was small a, which is capital A, moving towards right, and in the state Q8, I skip remaining characters of the first up. Those are either small a's or small b's. So the moves are AR, BBR. Let us not worry about this blank. Let us not worry about blank. Blank are that move in the state Q8 or in the state Q7. Both the things are same. Replica. Leftmost character is B. I'll follow the path Q6, Q7 onwards. The leftmost character in the first half is small a. I'll follow the path Q6, Q8 onwards. So leftmost A, first half converted into capital A. Then I have skipped remaining characters of the first half by the moves small a r, small b r, and then I'll find a capital letter. Input is small a, small b as per our example, followed by capital A, capital B, capital B. So I'll find capital A in the state Q8 after skipping the remaining characters of the first half, which are not yet compared. When I find A, I know that I am in the right path. Input may match. At least the first character of the first half matches the first character of the second half. So when I find A, I make it blank. So that is my strategy. I'll read a character in the first half, which is in the small case letter, as a marker. I'll convert into capital letter, go to the appropriate position in the second half, which is in the uppercase letter. If that is matching, I'll make it blank. So I make small case letter capital in the first half, and the match character of the second half, that is those characters are blank while moving towards left. So when I get A, which is a matching character in the second half, I make it blank, and then again I return. I move left. I start moving towards left because I have to match the new pair. I prepare for the next iteration. So I do A blank L, and then I perform AAL. Again, don't worry about blank blank L in the state Q9. A double B, capital A, capital B, capital B. The leftmost small a is now capital A. Remaining characters are small b, small b. Then in the second half, capital A was found. I have made it blank and A blank L. So I am positioned over small b in the first half. So in the state Q9, my moves will be BBL. The remaining characters are small b's. So whether it is small a or small b, I skip all the unmatched characters of the first half because I have to consider the second character from the left. It has to be A double B, A double B. I have to consider a new pair. So I skip all unmatched character of the first half by the moves AL, BBL. State is Q9, and ultimately I'll get, as per our example, I'll get capital A. Because the first character from left, the first character of the first half, that was A. Small a, I have converted into capital A. Remaining two characters, small b, small b. Second half, A, capital A, capital B, capital B. That capital A is now made blank. So I am returning towards left. I'll find small b's, I'll skip them. Ultimately, I'll find capital A. And because of that capital A, I know a character to its right. That is the first character of the new pair. So I do AAR. My moves are AR, BBR. In our example, it is capital A. So it is AAR, and I return to state Q6 so that I match. Again, I want to match two characters in the new iteration. So I return to the state Q6. Now Q6, our example, what has happened? My current string is capital A. Then I have two small b's. Then I have blank. Capital A, capital B, capital B. Out of that, the second half, the first character, capital A, that is converted into blank because it has matched. I'm back to state Q6. I'm back to considering a new pair. I'm prepared for the new iteration. Now I'll find small b because my input is, that was earlier, it was small a, small b, small b. First character has matched. So in the first half, that small a has become capital A. The remaining characters are small b, small b. So I'll find B. Second character from left in the first half will be small b. I convert that into capital B again as a marker so that I don't need to consider anything to the left of this particular B. So first half character now is small b. I convert that into capital B, Q6 to Q7. I repeat this AR, BBR, and now the boy is actually blank blank R also, because the whichever character has matched in the second half, as per our strategy, I make it blank. So whatever is has already been considered in the second half are in blanks, have been converted into blanks. So I have to perform blank blank R. By blank blank R, I am skipping the match characters in the second half. By small a r, small b r, I am skipping the unmatched characters of the first half. Leftmost unmatched character of the first half, I match with the leftmost unmatched character of the second half. So I'm doing AR, BBR, blank blank R, and now as per our example, I'll find capital B, because my second half currently is blank, capital B, capital B. I'll find a B. I started with B from Q6 to Q7. B in the first half, B has to be there in the second half, and once I find B, I make it blank. Same strategy. Matching character in the second half, make it blank. The character that I'm considering of the first half, convert into uppercase letter, so that I have to consider only the characters which are to its right. So I make that blank, B blank L, and in the state Q9, I have to skip the matched characters of the second half while moving towards left. So that move is blank blank L. The state Q9, the move blank blank L, that corresponds to the skipping of match characters of the second half. And then small a l, small b l, that is skipping unmatched characters of the first half. And again finding either capital A or capital B, I'll prepare myself for the next iteration. Therefore, I go to the state Q6. I repeat this process. Finally, what will happen? Everything will match as per our example. Small a, small b, capital A, capital B, capital B. That was the initial part in the state Q1. So what is in the state Q5? Maybe in the state Q5, fine. So what has happened? That becomes capital A. First half becomes capital A, capital B, capital B. My second half becomes blank. Everything has matched blank. So state will be Q6. State will be Q6. So ultimately I'll find blank. My first half becomes, in our example, A, capital B, capital B. The second half is blank, blank, blank. And the position of the head, because of this Q9 to Q6 move, the displacement is R. So head has gone to the first blank after the first half. My first half is now capital A, capital B, and because of the displacement R from the moves Q9 to Q6, the head is positioned over the first blank. That is the first character which has matched in the second half. In fact, all the characters have matched. So after this capital A, capital B, I have infinite number of blanks. So in the state Q6, ultimately I'll find a blank. That is the indication that matching is successful. I go to the halting state. I accept the string. So it is blank blank S to the HS state. So if you look at this output, it is something like blank. Output I have written, then S, which is in capital letter, blank, then capital A, capital B, and then I have a blank. So S is capital of the first half when I go to the halting state. Blank blank S, because of this S displacement, stationary displacement, head will be positioned over, will remain stationary over the first blank. That is the first match character of the second half at the time of reaching the halting state. And if you look at this Q0, Q1, HA, if my input is blank, then that is also to be accepted. Blank has to be accepted. So Q0 to Q1, blank blank R, I'll find a blank there. So Q1 to HA directly. Q0, Q1, HA, blank blank S. If I don't have any non-blank character, I don't need to go to Q1, Q2, Q3, Q4. Straight away Q0, Q1, HA, that is blank blank S. So that completes constructing a TM for accepting the language SS. Any query? Any doubt in this? Is it clear? If anyone has a doubt, can unmute and ask me. If anyone has a doubt, can unmute and ask me. Priyank, fine. Okay, Devansh, Keval, Munaf, fine. So we took an example of a language that cannot be accepted by either a finite automata or PDA, and that is the language SS. Only TM can accept, only Turing machine can accept this language. Neither finite automata nor PDA can accept this language. Fine, we take one more example, and it is drawing a transition diagram for a Turing machine accepting the language a raised to I, b raised to j, where I is less than j. It should be a straightforward case. Think about the logic, not a difficult example. Draw a transition diagram for a Turing machine accepting the language a raised to I, b raised to j, where I is less than j. Should be a straightforward case. Turing machine accepting the language a raised to I, b raised to j, where I is less than j. So my first half, my initial part only is, and then I have b's, a raised to I, b raised to j. I have I number of a's, and then I have j number of b's. Something like, say, b, a, not acceptable. Initial part has to be all a's. How many a's? I number of a's. Then I have j number of b's. And I is less than j. So a double b, that is fine. Number of a's is 1, number of b's is 2. I less than j. That is the constraint. All a's at the beginning, then I have all b's, and I should have at least one more b than that of a's. That is the requirement. So maybe not difficult to think about this logic. Having done this SS, I think this should be a straightforward case. Multiple ways we can construct the transition diagram. This is one of the solutions. This is one of the many solutions. So Q0 to Q1, the typical move, blank blank R. My input format is blank X. The actual input begins from cell number 1. The content of cell number 0 is blank. So by blank blank R, I go to cell number 1. State is Q1. I have reached state Q1. Then I must have first character is A raised to I, b raised to j. So I have fewer number of a's than number of b's. So let us take the straight line. Let us look at those transitions. Let us not worry about the below transitions, below Q1. So let us take this transition. My leftmost character, that is A, I make it blank, and then I skip all A's and B's. I skip all A's and B's. On getting blank, we are taking here the palindrome approach. We are going to the extreme. Already I have matched 1A. So I'm going to the rightmost B and making it blank. That approach we are taking. Blank blank R. Leftmost A, I make that blank. Then I skip all A's and B's yet to be matched. On getting blank, I go to state Q3, and corresponding to A, I must get a B because I required at least one more B than number of A's. So in the state Q3, I must get B. I make that blank. The leftmost A, I have made it blank. The rightmost B, I have made it blank. So the leftmost A, which I have made blank, that is a transition between Q1 to Q2. And the rightmost B, which I have made blank, that is a transition between Q3 to Q4. So again, from the extreme, we are moving towards the center. We have taken the approach that we took while constructing the TM4 palindrome. So in short, we'll call that the palindrome approach. So in the state Q4, once we reach Q4, we know for the current A, current B was found. Again, we are returning, going to consider one more A. So in the state Q4, we make the transitions. The moves are BBL, AB, AL, and on getting blank, we move to the right. So again, we repeat this. That is our loop. Next A, Q1 to Q2. Next B, from the rightmost side, the rightmost B, that is Q3 to Q4. So suppose my input is of the form double A, triple B. So I have two A's and three B's. I is 2, J is 3. The string has to be accepted. So what happens in the state Q1? Now I won't have any A. All the A's I have made blank. Corresponding B's I have made blank from the right. I must get at least one B because J has to be greater than I. So in the state Q1, I must get B, at least one B. So once I get a B, I must have remaining B's also. So in the transition between Q1 to Q5, that is BBR. Instead of getting A in the state Q1, when I get B, I know that everything else has to be B's. My initial part, the prefix all A's, the suffix all B's, and at least one more B, then number of A's. So in the state Q1, I must get a B. Not only that, subsequently I must have all B's. So in the state Q5, I perform BBR, and then eventually I'll get a blank. I go to the halting state. So because I have erased B's from the right, additional B's, the more B's, then number of A's, that will be concentrated after my initial A's. Again, once more an example, double A, for example, double A and 4 B's. So initial 2 A's, I have made 2 blanks, and then corresponding 2 B's from the right, I have made blank. So in between, I have concentrated B's. So in the state Q1, when I get a B, next characters, all characters must be B's. So Q1 to Q5, that is BBR, and in the state Q5, once again, that is BBR. And then it is blank blank S. After all skipping all B's, I must get blank. So once I get blank, I go to the halting state. And this BBR, I mean, I cannot merge Q1, Q5, I cannot merge. I require at least one B. Otherwise, I don't want to accept a string of the form AAA, BA, triple B. What happens? See, from left there are 3 A's. From right there are 3 B's. And then in between, I have BA. So my prefix has to be all A's and the suffix has to be all B's. If a string is of the form AAA, BA, triple B, and if I don't have this BBR moves, then that will be accepted, and that will be wrongly accepted. So the moves between Q1 to Q5 BBR and then Q5 BBR, that ensures that towards right I have all B's. I don't have A's in between, because a string of the form AAA, BA, triple B has to be rejected. So this is my TM for accepting the language A raised to I, B raised to J. Is that clear? Okay, Priyank, Jainil, fine, Keval, Devansh, and maybe, I mean, we can solve this in many ways. Alternate approach is our SS approach. This was our palindrome approach. When we say palindrome approach, it is processing from the extreme and moving towards the center. That is our meaning of palindrome approach. Similarly, when we say SS approach, the meaning is going from the leftmost part and then processing from the middle. That is the second part. That is our SS approach. So the second solution, that is more of an SS approach. The first solution, that was the palindrome approach, because A we read from the left, B we erase from the right. The rightmost B we erase first. So from the extremes we are moving to the centers. Let us see. Let will change in the solution number 2, where we are taking the SS approach. So blank blank are no change in the move. Blank blank are the typical first move. State is Q1, then Q1 to Q2, small a, capital A. So we are reading in A, small a, converting into capital A, that is our marker, and then skipping all A's in the state Q2, small a r, and then skipping B's, because as soon as we get small b in the state Q2, we convert into the capital B. So something like small a, and then B. So leftmost A we convert into capital A, then skip all small b's. As soon as then skip all small a's, and as soon as we get a small b, we convert into the capital B. We don't wait for the extreme. We don't go to the rightmost B. So that is our meaning of our SS approach. In the state Q2, getting small b, we make it capital B. And once we get that, then we skip capital B's, because these are the B's that have already been matched in the second part, and also we skip small a's. These are all unmatched A's in the first half. And getting capital A, again we repeat our process. So that is Q3 to Q1, capital A R. So finally, when we get B in the state Q1, when we get capital B, it means our matching of A's with the B's is over, and there has to be, that is BBR, Q1 to Q4, and again Q4, that is BBR, and there has to be at least one more B. So that is ensured between Q4 to Q5, because the requirement is J greater than I. So all match A, those are in capital A, all match B that are in capital B from the left in this approach. So in the Q1 state, after we have completed matching of A's, we'll find a small b, and we have to skip all B's. That will be the state Q4, and at least one additional B, and that will be in this small case letter, because the matching are all in capital letter. So when we get small b in the state Q4, we know that this additional B, our requirement J greater than I, that is over, and remaining has to be all B's. So that is state Q5. We cannot have A's after that. We can't have any A's. Once B starts, we cannot have any A's. Therefore, in the state Q5, we have BBR in the state. And if my input contains only B's, then I make a transition from Q1 to Q5. I make a transition between Q1 to Q5. My input, suppose, is say blank B. My input has only one B. Number of B's is 1, number of A's is 0. B belongs to the language. So in that case, that Q1, Q2, Q3, that path will not follow. Rather and because there is no matching, so nothing will be in, no B's will be the capital letter. So we make a shortcut, Q1 to Q5. Only one additional B is required, that is small b R. And then in the state Q5, we can have any number of more B's. And then that is finally blank S going to the halting state. And the same case was there in this palindrome approach. Once we find additional B in the center, all B's, and eventually we'll get a blank. So that is how we move to the halting state. Q5 to HA, we must have a halting state to accept a string. So that is blank S halting state. And unlike other models of computations, once the halting state is reached, we don't need to process the remaining input. That is how operationally Turing machine is different than other models of computation. So here also, Q5 state, once we get a blank, we go to the halting state. So that is our SS approach, and we cannot merge Q4 and Q5. We cannot optimize, we cannot merge states Q4 and Q5, as remaining entire string needs to be checked and should not contain any A. That is the reason we cannot merge Q4, Q5. If we merge Q4, Q5, then it will also accept a string of the form AABB. So instead of Q4, Q5 only, suppose we have Q4 state, then we'll have the same number of A's and B's, AABB. that will also get accepted, and that cannot be. There has to be at least one more B. So this is our solution number 2, taking the SS approach for constructing a TM accepting A raised to I, B raised to J. Any doubt? Any question? Any question in this? If anyone has something to say, anyone has anything to say, can unmute and ask me. Is this clear? Keval, Priyank, Janil, Love Patel, fine. Devansh, okay. Kaushal Chovatia, fine. Munaf Divan, fine. Okay. So let us go to the next example. A raised to n, B raised to n, C raised to n. That was our first language. While introducing TM, we have taken 2 examples. L1 was this: A raised to n, B raised to n, C raised to n. See, many similar examples are asked in the gate. Even if you must have some idea about gate 22. Many questions were there on TOEFL, and there you have to find out whether the current given language is context free language or not. So if you have this idea, if you conceptually understand this, then it will be much easier for you to decide whether the given language is CFL or not. Whether the given language is CFL or not. Fine. So the third example, A raised to n, B raised to n, C raised to n. In fact, the 6th example, and this was our first example of a language which is not a CFL. No PDA exists. No PDA exists for this language. Non-CFL language. It's not a CFL language. No, this is not a context-free language. No PDA exists, cannot be context-free. This was our first example. Examples of languages that cannot be accepted by PDA. It means these languages are not context-free languages. L1, L2. No PDA exists, no context-free grammar exists for accepting or generating language L1. For L2, we constructed a TM. Now we take the example of L1. We'll construct TM for L1. PDA does not exist. This one. A raised to n, B raised to n, C raised to n, where n is greater than or equal to 0. Again, having done these many examples, particularly SS, and now A raised to I, B raised to J, I think more or less the approach is clear. You have to accept the language A raised to n, B raised to n, C raised to n. So we'll match 1A, 1B, 1C. And this language cannot be a CFL because you have to match not only A's and B's, but C's also. You have to compare A's, B's, and C's together. PDA has only one stack. A PDA has only one stack. So we cannot match number of A's with both number of B's and number of C's. We can match number of A's with B's, that is fine. But we can't match A's with B's and C's together. Therefore, this is not a context-free language. Therefore, a PDA does not exist. A raised to n, B raised to n, C raised to n. As far as Turing machine is concerned, it is very simple for us to match 1A with 1B with 1C. Same, SS approach, we were matching first half with the second half. Here, maybe the third half. SS was much difficult than this because here we exactly know where my second part begins because it is beginning with B's. I know where my third part begins. It is beginning with C. So something like triple A, triple B, triple C. I don't need to worry about identifying where my second half begins, which was the case in the SS. These are relatively simpler examples because I am aware of where to match, what to match. There I was not aware where to match in the case of SS. Therefore, in that case, we required this particular part. This part, identifying where the second half begins, locating where the second half begins, and then going to the last part, last character of the first half, this ALBBL, and then going to the beginning, going to cell number 1, where the first half everything in small case letter, second half everything in capital letter. So we needed to do processing. We needed to do processing in the case of SS. Here we don't need to worry about that, because I know it is all A's, then all B's, then all C's. Then only I have to accept, otherwise I have to reject. If it is not following this pattern, I have to anyway reject. So I don't need to worry about defining those transitions. So per iteration, I'll match 1A, 1B, 1C. Q0 to Q1 blank blank R, that is my typical move. Going to cell number 1, state is Q1. So I'll match small a and convert into capital A. Per iteration, I'll match 1A with 1B with 1C. And these all will be converted into equivalent uppercase letter. State is Q1, small a I have found, I have made that into capital A, the displacement is R, and then remaining characters of the first half, small a's, I ignore in the state Q2. So it is A, R, small a, R. Not only that, the match B's of the second half, again I have to ignore. I'm looking for one small a, one small b, one small c, and once I find that, I make that into capital A, capital B, capital C in one iteration. Q1 to Q2, I have already converted small a into capital A. So I skip remaining small a's, that is my A's half or the first half. I skip the match B's of the second half, then I'm looking for small b. So once I get small b, I convert into capital B. I continue moving towards right because still I have to match 1C. So in the state Q3, small b are, so remaining b's of the second half I skip, the match C of the third half I skip, that is capital C are, the state is Q3. That bigger C means these are match C's. Once I get small c in the state Q3, I convert into capital C, and then I start returning. The displacement is L because I have already matched 1A, 1B, 1C, and then I don't need to go towards right. I start returning. So the displacement is L. The state is Q4, and in the Q4 I do the reverse. The match C's, those are capital C's. In the third half, the displacement is R. The displacement is L. The displacement is L. So it is capital C, L. Those are match C's of the third half. Then it is B, L, capital B, L. These are all match B's of the second half. And small b, L, these are all unmatched B's. These are all unmatched B's of the second half. And then small a, L, these are all unmatched A's of the first half. I continue moving towards left, and as soon as I get a capital A, it means my current iteration matching 1A, 1B, 1C, that is over, and then I have to repeat. So in the state Q4, when I get capital A, then I start moving towards right and prepare for the next iteration, returning to the state Q1. Returning to the state Q1, capital A, capital R. Once I get capital A in the state Q4, I know I have to try the next iteration. So instead of the displacement L, that becomes displacement R. I back to state Q1. So something like say double A, double B, double C. I have made this in that after first iteration, that becomes capital A, small a, capital B, capital C, small c, and I have skipped everything. So I have made, now I have been placed, the head is placed over the first small a in the state Q1. I repeat this. So once everything is converted, assuming that it is of the form a raised to n, b raised to n, c raised to n, I'll find in the state, because say 3 a's, 3 b's, 3 c's, so those have become 3 capital A's, 3 capital B's, 3 capital C's, and because of this displacement R, is in fact this A, as per our example, is the third A, and because of the displacement R, our head is positioned over the first B. So in the state Q1, when I find B, I know that matching is over. So I do BBR and go to state Q5 and then skip the characters, remaining characters of the second half. So it is BBR. I will get C, that is CCR, and then skip CCR in the state Q5, then continue skipping C's, that is the third part. And finally, I'll get a blank in the state Q6. It means my input was of the form this A raised to N, B raised to N, C raised to N, everything we have converted into the capital letters, getting blank, I move to the holding state. I move to the holding state. If my input is only blank, because N is greater than or equal to 0, so blank has to be accepted. So I make a transition Q0, Q1 to the holding state, Q0, Q1 HA, Q0, Q1 HA, and that is blank blank S. I don't have any A or B or C. So nothing will be there, Q0, Q1 HA. In the transition Q1 to HA, you can see that is blank blank S. That is how I accept the string blank. Blank belongs to the language. So this is a TM for accepting A raised to N, B raised to N, C raised to N. Maybe we can have instead this also. I think we'll discuss this. We'll discuss this in the next lecture, part 2. This is over. Maybe little optimization we can make in this. We'll discuss that in the next lecture. Can we make it or not? We'll discuss that in the next lecture. This is fine. This is absolutely fine. TM for accepting language L we have constructed. Any doubt in this? Is it clear? Keval, Devansh, Jainil. Okay, that's fine. And we'll stop today's. We'll stop here now. We'll continue in the next lecture from this point.